which means in this calculation, you just move this whole thing in here. Perpetuity. I'm going to use a brown pen. It is unequal cash flows. It's a infinite equal cash flows occurred at the end of each period. Until forever. So on the timeline, I need to have this sign for infinity. It's forever. Okay. Then how to make the judgment? How to identify its perpetuity? Number one, same as annuity. So still compare with annuity. Finite and equal cash flows. Number two, infinite cash flows, which means n is going to be infinity. Okay, so this is different from annuity. Number three, same as annuity. That means cash flow occurs at the end of each period. And for the same time intervals between every two cash flows, that's the same as annuity. So you can see that we can use these guys as a benchmark. For the other two, one difference in here. For the second one, a difference in here. How about the present value calculation? Present value of annuity, of perpetuity. Equals C over R. There is no n because n is infinity. Okay? And then I'm going to remind you. Two reminders. Number one, in your calculation, C, R, and n. Okay, if we're talking about these two, must have the same time unit, which means we discount in an annual period, then we use annual rate with the annual cash flow. If we discount at a monthly rate, use number of months with monthly cash flow. Number two is a little bit more challenging. It's a problem with the delayed first cash flows. That means, like for example, for annuity or for perpetuity, your first cash flow is no longer occur at 1, but at maybe time 5, time 6 in the future time. Well, annuity due, your first cash flow is not occurring now at the beginning of the first period, but maybe at the beginning of the 10th period. So you have a delay for a couple of years, for some years, before you would see your first cash flow in order to decide it's an annuity or annuity due. For this case, if you still want to use the present value equation, okay, if you still want to use the present value formula, okay, you need to consider two scenarios. Number one, for annuity and perpetuity. The PV formula tells us a value at one period before the first cash flow. That means if you use this equation, you want to use this equation to get the present value. This formula can only tell you a future value. that is at one period before the first cash flow. You need to discount this result back for another period on the timeline. For annuity due, the PV formula tells us a value at the same time of the first cash flow. I'll draw the example for you. Okay, if I talk about a delayed annuity, I have 5 cash flows. The first cash flow occurs at the end of year 4. So if you use present value equals C over R times 1 minus 1 over 1 plus R to the power of 5 in here, this equation's value is a value at one period before the first cash flow, which is in here. Actually, this is your value. You have one value in here, not present value. Thus, you need to discount this value for another 3 periods back to present. That's how to solve the problem with a delayed first cash flow. If you consider this guy as an annuity due, this one occurs at the beginning of the 5th year. This one occurs at the beginning of the 6th year. If you consider that as an annuity due, then I use the green pen. If you use present value of annuity due, it tells you the value exactly at the same moment as your first cash flow. But still, you need to discount this value back to present for another time. In this case, you need to discount back for 4 more months back to present. That's the second reminder in calculation. So that's the clip about the 3 special cases in our discussion. And at the end of our class notes, I have a wrap-up tree for the whole structure of this chapter. Thank you.